The metals to be soldered may look perfectly clean, but most metals will quickly oxidize whenever they are exposed to oxygen in the air. You might think of flux as a special kind of soap that removes oxidation or cleans metal so it can bond properly. The second job of the flux is to prevent the freshly cleaned metals from being re-exposed to oxygen in the air in order to keep the surfaces from reoxidizing. The liquid flux will cover or protect the freshly cleaned metal until the flux is displaced by the solder. The third job of the flux is to assist in the transfer of heat from the tip of the iron to the metals being soldered. As an example, if you were to touch your hand to a hot frying pan, you might get away with it if you touched it very quickly. But if you were to add some oil or liquid to the pan, the transfer of heat would be much faster. This should explain how the flux helps to spread or transfer the heat from the tip of the iron into all of the metals that it touches. The hand soldering operation usually happens very quickly, and it's impossible to see everything that's going on since the parts are very small. So let's examine an animated hand soldering operation to observe how everything works. First, the tip of the iron is applied to the junction of the land and the lead to be soldered. This starts the heat flowing. Next, a heat bridge is formed by touching the solder wire to the same junction. This starts the flow of the flux and the initial melting of the solder. The flux moves away from the heat and ahead of the solder over all of the metal surfaces. The heated flux removes oxidation or contamination from the metal surfaces. Everywhere the flux touches, it helps to heat up the metals. All of the metal surfaces need to be at the proper temperature or the solder won't bond properly. Now the solder wire is moved over to the opposite side of the land, while the solder and flux continue to melt. Liquid solder will move toward the heat. That's why we want the solder to flow from the opposite side of the heat source. Otherwise, we might not get enough solder to flow over onto the unheated side. The flux is pushed along by the solder as it performs its cleaning job. As it moves in front of the solder, it also floats away the loose contaminants. The flux and oxides will end up pooled around the edges of the land after the soldering operation is completed. To demonstrate the basic technique, we'll be soldering a round component lead into a plated through hole. Normally, this type of soldering operation would only take a few seconds to complete, but we'll be stopping the process in order to explain everything that happens as we go along. We begin by gently placing the cleaned and tinned soldering iron tip against the lead and the land. This will transfer heat into both of these parts. Now the solder wire should quickly touch the tip of the iron to melt just enough solder and flux to form a heat bridge between the metals. Then we'll move the solder wire over to the opposite side of the joint, still touching both the lead and the land. When there's enough solder melted into the connection, the solder wire is removed, followed by the soldering iron tip. Then we'll inspect the joint to make sure it looks right. A preferred or target connection is where all of the metals are covered by solder and the outline of the lead remains visible within the solder connection. Here's what the same operation would look like at normal speed. Notice how quickly this all happens. Let's review the process once more to highlight some of the problems to avoid during hand soldering. The tip should lightly contact both parts to be soldered. Pressing down firmly with the tip will not transfer the heat faster, but it may damage the land or the base material. Only a small amount of solder should be melted against the tip of the iron. If you melt all the solder by touching it directly to the tip, you may not get enough solder to flow onto the other side of the connection. Remember that solder flows toward the heat, flux flows away.